Hi Tom.
Hi James.
What about the weather?
What about helicopters?
You know, funny you should ask, because I just happen to know. Let me cut it there, right? The mechanics of helicopters form the backbone of the science behind them. You have two main types of rotor helicopters, tandem and coaxial. You tend to see tandem in Chinook helicopters and coaxial in single rotor helicopters. Now the basic principle behind a helicopter is that you have a set of rotor blades that spin in one direction to create lift. However, because they are spinning in one direction, according to Newton's third law, the helicopter itself will spin in the other way. So to counteract this, they use a second rotor on top that might spin in the opposite direction. In a coaxial helicopter, or in a tandem, they might have one at the back that spins the other way. Either way, if there was just one rotor, they would use the blade at the back of the helicopter to counteract the forces. Two types of flight for a helicopter: hovering flight and powered flight. With powered flight, the thrust forces made by the engine of the helicopter will be greater than the weight, thus creating a resultant upwards force. The other type of flight is hovering. With hovering flight, the forces of thrust must equal the forces of weight, and to change the altitude of the hovering, the power can be varied in the engine or the angle of attack of the plane of rotation. A counterproduct of thrust with helicopters is torque. The problem with torque is that when the engine turns the rotor blades in a counterclockwise direction, because of Newton's third law, a force turns the main helicopter body clockwise, and thus to eliminate this, a second set of rotors is placed on the helicopter or a tail fin to cut out the torque. Now, a crossover between aerodynamics and mechanics would be the function of the blades themselves. They function very much like plane wings in that they are aerofoils designed to create less pressure at the top of the wing and more at the bottom, which creates lift in the process. And while they spin, they force the air under the wing and some over the top, and the ones at the top tend to work faster, and the air below tends to go slower, thus creating the pressure difference and thus the lift. So, on one of the more complex notes in regards to the mechanics of helicopters, we have something called gyroscopic precession. Now, I know it sounds very complicated, but fear not, I'm here to explain. When you have an axis spinning, there is a resultant force that forces the axis in the direction it spins, perpendicular to its platform. Stop.
It's fine.
As you saw in the previous shot, I had my two trusty assistants, Tom Hopper and James, spin the wheel for me. So as we spun the wheel clockwise, there was a resultant angular momentum in that direction, and then when James let go and I lifted the wheel, there was a resultant force from me going upwards perpendicular to the angular momentum, and thus, because of gyroscopic precession, ladies and gentlemen, the axis turned perpendicular to the spin of the wheel. And that concept is replicated in a helicopter in the other direction, which allows it to move forwards and sideways.